Hi, this is Emily Loeb, and this is my presentation about Saturn. So I'm just going to start screen sharing, minimize myself so you can see my full screen, and then we're going to get started. So like I said, I decided to do research on Saturn for my planet project. And Saturn, to begin, just Saturn is the sixth planet from the Sun. It is behind Jupiter and in front of Uranus, and as you can see in that picture, I arrowed where Saturn is. Saturn's average distance from the Sun is about 886 million miles, and 886 million miles is equal to about 1.4 billion kilometers. Saturn's minimum distance from Earth, so basically when Saturn and Earth are at their closest, they are 746 million miles or 1.2 billion kilometers apart. So just to get into the details about the mythological origin of Saturn, he was a Roman god of agriculture, and more specifically, he was the god of seed corn. His mother was Terra, and his father was Caelus. And Saturn was also the father of Ceres, Jupiter, Veritas, Pluto, Neptune, and Juno. And Saturn ruled Latium during its golden age, and it was a time of prosperity and peace. And he really instructed his people on the basic principles of farming, and he helped them adopt a more civil lifestyle. So how did Saturn get his name? Romans knew of 7 objects in the sky, which were the sun, the moon, and the 5 brightest planets. They named these objects after their most important gods. So therefore they named Saturn after one of their very important agriculture gods, whose name happened to be Saturn. But it's also proposed that because Saturn was also the god of time, that Saturn was named Saturn because out of the 5 brightest planets, Saturn is the slowest to rotate around the sun. So the diameter of Saturn is 72,367 miles, and that's equal to about 116,464 kilometers. And the major rings of Saturn actually have a diameter of 270,000 kilometers. So just to compare Saturn and Earth, the mass of Saturn is 95 times the mass of Earth, and Saturn's diameter is 72,367 miles, and meanwhile Earth's diameter is just a small 7,917 miles, and this makes Saturn 9.1 times larger than Earth. And then as I was doing my research, I came across this really good quote on NASA's website. And it says that if Earth were the size of a nickel, Saturn would be the size of a volleyball, which is a really great comparison of the 2 planets. So next I'm going to talk about the gravity on Saturn. Saturn's gravity is 1.08 times Earth's gravity. So Saturn's gravity is 10.44 meters per second squared, and Earth's gravity is 9.807 meters per second squared. So if an object weighed 100 pounds on Earth, it would weigh about 108 pounds on Saturn. Next, we're going to go into the temperature range of Saturn. Temperatures in Saturn's atmosphere increase along with pressure as one travels closer to the center of the planet. And the average temperature of the planet is negative 288 degrees Fahrenheit, which is equal to negative 178 degrees Celsius. So just to talk about the temperature and the layers of the atmosphere, so the furthest layer of atmosphere from the core is ammonia ice layer, and that's about negative 280 degrees Fahrenheit, which is negative 173 degrees Celsius. That is the lowest temperature of the planet, the furthest out you can get. The next layer of the atmosphere, as you're getting closer to the core, is the water ice layer, and that's about negative 127 degrees Fahrenheit, and that equals negative 88 degrees Celsius. So as you can see, we are getting warmer as we go closer to the core. And the lowest layer, which is closest to the core, is about 134 degrees Fahrenheit, which is equal to 57 degrees Celsius. So that is the high of the planet. And here is a YouTube video just explaining the atmosphere layers and temperature.
Writing's not that easy, but Grammarly can help. This sentence is grammatically correct.
Hi, my name is Aileen Perez. I'm an astrophysicist, and this is Saturn's average high and low temperatures in Fahrenheit. So a notable way to look at the temperature is to actually just look at the atmosphere. The atmosphere is quite important. So when you look at the atmosphere, the top layer has ammonia ice. And the temperature is actually between minus 280 degrees Fahrenheit to about 170 to minus 170 degrees Fahrenheit. So that's pretty cold. Then you move lower and you have actually a water ice layer, and that's between minus 127 to 26 degrees Fahrenheit. So as you can tell, you're moving towards the inside of the planet, and the planet's getting warmer. And then here, the last layer closer to the ground in the atmosphere, you can get up to about 134 degrees Fahrenheit. Now, in total, the average planet, the average is minus 288 degrees Fahrenheit. And that's the average temperature of Saturn. My name is Eileen Perez. I'm an astrophysicist, and this is the average temperature of Saturn.
All right, so that was a good explanation there. Next is just going to talk about a little bit what Saturn looks like. So its color is a pale yellow with hints of orange. It can also appear gold when we look at it from Earth. It has a lot of clouds surrounding its core. It appears as a banded pattern, which causes its stripe-like appearance. And the dark regions are free of high clouds, and the bright regions on the planet are areas with thick high clouds, so you get that stripe appearance. And then, of course, Saturn's most renowned feature is its rings. And there are 7 main rings, and they're named rings A through G, not in alphabetical order though. And there's gaps between each ring, and each ring is made of billions of small chunks of ice and rock. And the ring particles mostly range from tiny dust-sized icy grains to chunks as big as a house, and some chunks are as big as a mountain. And then each ring orbits at a different speed around the planet. And here's another quick video just going into depth about what the rings look like.
I like me for me. I'ma be what I'ma be.
Alright, so I thought that was a pretty cool video and just showed you some up-close photos of what the rings look like. So some common elements present on Saturn. Saturn is a gas giant, and its surface is completely made of gas. It has a similar composition to the Sun, and it's predominantly composed of helium and hydrogen gas. But it also has ice, which is a solid that contains ammonia, methane, and water. So the atmosphere of Saturn, like I had previously discussed on the temperature slide, that there's about 3 layers, but the planet lacks a solid surface, so there's no direct transition between surface and atmosphere. But like the surface, Saturn's atmosphere is mostly made of hydrogen and some helium. It's about 96% hydrogen gas and 4% helium gas. And there's also gases such as sulfur, methane, ammonia, nitrogen, and oxygen that lie within the planet's atmosphere and create the colorful bands along with the clouds. And there's also winds in the atmosphere, and the winds in the upper atmosphere can reach up to 1,600 feet per second. And just a little comparison, the strongest hurricane winds that we've ever felt on Earth are 36 or 360 feet per second. So totally different. But yeah, there's just a little picture there. It's comparing it to all the atmospheres. And yeah. So just to move on to the names and characteristics of Saturn's moons. Saturn has 53 moons, actually, and there's another 29 moons awaiting confirmation, so that was definitely too many to do research on, so I picked the 8 major moons. And the first major moon is Titan, and Titan was the first moon to be discovered. It actually has its own atmosphere made of nitrogen and methane, and it's larger than the planet Mercury, and it has many tall mountains and hydrocarbon-filled lakes. The next major moon is Dione, and it is a dense rocky core surrounded by water ice. It has many craters on its backside, and it has a thin oxygen atmosphere and may have a liquid ocean beneath its surface. The next moon is Enceladus, and it has more than 100 geysers at its south pole. And it has a very icy surface, but it is one of the brightest objects in our solar system due to that. And it also has a subsurface ocean that may hold life, so that's super important. The next major moon is Hyperion, and it's a small moon with an irregular appearance. It kind of looks like an elongated potato, and it has a low density and porous surface, which makes it pretty spongy. The next 4 major moons are Iapetus, and it is a walnut-like shape. It's got a light and dark contrast on its surface, so it kind of almost looks like a yin and yang sign. And it hosts some of the tallest mountains in our solar system, which is pretty cool. The next major moon is Mimas, and that has a rocky surface with a gaping crater, and it kind of looks like the Death Star from Star Wars, and as you can see, I put a picture of it on the left there. It really does look like the Death Star, which is pretty funny, but it's a good way for us to compare. So Mimas is the smallest and closest orbiting moon of the major moons, and it is made of primarily water ice. The next moon is Rhea, and that is a heavily cratered moon that lacks a core. It is made of completely ice, and NASA described it as looking like a dirty snowball. And it is the second largest of Saturn's moons, and it contains a faint oxygen atmosphere, which is the only oxygen atmosphere other than Earth in our solar system. And the last major moon is Tethys, and that one travels close to Saturn and feels its gravitational pull. It is made mostly of water ice, which slightly melts actually from the heat that Saturn gives off. And there's actually a large trench that crosses the moon, and it spans about 3/4 of the moon's circumference. And it also has been discovered that Tethys has large red arcs on the moon, which scientists really have no explanation for yet. The probes that have been sent to Saturn, there's 4 robotic spacecraft that have been sent there. The first was Pioneer 11, which was sent in September 1979. It gave us really the first close look at Saturn, and it had really just been seen through telescopes before then. It discovered a planet was made of mostly hydrogen, and it also discovered the F ring of Saturn and 2 moons. And lastly, it found evidence of Saturn's bow shock, which is the spot where Saturn's magnetic field shields the planet from the effects of the sun. So basically, Pioneer 11 was the first to discover the evidence of Saturn's magnetic field. The next robotic spacecraft that was sent was the Voyager 1 in 1980, and it discovered 3 new moons, and it also discovered Titan's thick atmosphere of nitrogen. The next was Voyager 2 in 1981. Voyager 1 and Voyager 2 were only 9 months apart, and Voyager 2 provided more in-depth information and pictures of Saturn's rings, so that was Voyager 2's main mission. And the more recent one is Cassini, and that was in 2004, and it studied Saturn in orbit for 13 years. It also carried the Huygens probe that was sent to Titan in 2005, and the Huygens probe really gave us some detailed information about Titan, which is one of Saturn's moons. And Cassini also discovered that some of Saturn's moons, Titan and Enceladus, may be hospitable to life. It also discovered the evolution of Saturn's rings, and it discovered the hexagon storm, which I discuss further at the end of this presentation. And Cassini also discovered 30+ moons, and it basically just learned more about Saturn's rotation rate as well. So a big question is, can life exist on Saturn? So Saturn, the planet itself, cannot support life. The temperature, pressure, and materials that make up the planet are way too volatile and extreme for organisms to live and adapt. However, a lot of research has been done about two moons that may be able to support life, and these two moons are Titan and Enceladus. So both are home to internal oceans that could support life. Titan has a water ice in its crust that could melt into liquid water, and that water could support life, since we know that water is the only solvent that can do that. And Enceladus has a global water ocean beneath its icy surface. And this ocean is salty like the Earth's. It contains an abundance of organic molecules. And there's also a possibility of hydrothermal activity on the ocean floor similar to that of Earth. And I don't know, that sounds pretty convincing. But we'll see in the future. And lastly, some unique characteristics of Saturn. Like I discussed previously, its most renowned feature is Saturn's rings. And another unique characteristic is time on Saturn. It holds the second shortest day in our solar system. One day is about 10.7 hours. And Saturn also has an interesting year. So Saturn makes one complete orbit around the sun in 29.4 Earth years. And its axis is tilted 26.73 degrees, which is pretty similar to Earth's tilt. And like Earth, Saturn has seasons. And the last characteristic that I wanted to talk about was the hexagon storm on Saturn. That is what's pictured to your right. It's actually a six-sided jet stream at Saturn's north pole, and it's basically a massive hurricane with an eye 50 times larger than the average hurricane on Earth. And then here's my last video just to go a little more in depth about the hexagon storm.
The Soviets might be trying to introduce a new weapon.
Once we do this thing, there's no going back.
It's springtime on Saturn, and the hexagon is out. A perfect six-sided hurricane, 60 miles deep, that could swallow 4 Earths. It's ringed by winds of ammonia and hydrogen blowing 220 miles an hour. The storm was seen by the twin Voyager spacecraft when they passed by in the early 80s. That was the last time until recently that sunlight graced the North Pole of Saturn, which takes 30 of our years to make one circuit of the sun. Soon after the Voyagers departed, winter descended. Saturn's rings tipped away from us, plunging the North Pole into 15 years of darkness. Without sunlight, astronomers were limited to infrared images. They showed the hexagon was still there. But what is it? The hexagon is a narrow jet stream that circles the North Pole. Researchers think that friction with the slower clouds on either side of it creates eddies, mini-storms that push the jet stream into a wave-like shape as it goes around. By spinning columns of water at different speeds, scientists have been able to reproduce the six-sided pattern in the lab. In January of 2009, the sun began its slow rise in Saturn's north. Summer was coming. The Cassini spacecraft was there to see it. In the coming months, Cassini will slip between Saturn and its rings to pass right over the storm for a closer look. But that's not all there is to see up north. Saturn has an aurora, its own version of the Northern Lights, a ring of electrical fire guided by the planet's magnetic field. Rings of ice and a dancing ribbon of aurora sitting smack on top of a six-sided hurricane. Another jewel in the crown of the solar system's most photogenic planet, where the voyage and the discoveries go on.
All right, so pretty crazy, but super interesting as well. And that's it for my presentation. These are just my references, and that's it.